Welcome, everybody, to the Tree Fund webinar series. My name is Bo Broadbeck with Auburn University, and it is a pleasure to be able to serve as the host and co-moderator for the Tree Fund webinar series. We have another great webinar for you today from a researcher coming to us from Davie, looking at some entomological pests. And we also have with us a student from one of our uh, scholarships that Tree Fund offers. Welcome. Thank you for joining us today. And now I'd like to introduce my co-moderator, Heath Hupke with Tree Fund.
Yes, well, welcome. It's been too long, it feels like. So for those that are attending for your first Tree Fund webinar, welcome. Uh, Sit back, relax, enjoy the show. For everyone, good morning, good afternoon, good evening from wherever in the world you are attending. And for those that are regulars, welcome back. I know this is a busy time, at least here in the United States. It's summer, so it's a time that we should be outside as able. And so it's great that so many of you are taking time aside and spending it here with us during this webinar. And we are Tree Fund. So for those that don't know us, that's Tree Research, Education, and Endowment Fund. And with that, we do want to recognize companies that support research through Tree Fund by investing in research that is available to everyone. They help us be able to advance safety, urban forestry, arboriculture, and tree care practices across the industry, such as this webinar right now. So thank you to Asplund, ISA, Bartlett, Corteva, and Lucas Trees as our crown partners. And thank you to our platinum partners of First Energy, Save a Tree, and Right Tree. Next, again, Tree Fund stands for Tree Research and Education Endowment Fund. We are a nonprofit or a non-governmental organization, and we rely on donations and support from individuals. So if you find today or past webinars that you've been a part of helpful and you'd like to continue to support our mission, these webinars, we always appreciate your support through donations. But for those that are able to, thank you. And we will continue to supply these webinars free of charge and make them available for you. I do have some housekeeping pieces. So prior to my introductions, I just kind of don't tune out any part of this webinar, but we do have some really exciting things that I want to kind of let you know about. But as a reminder, we do have a Q&A function in this. So please, if you have any questions while Dr. Whitney is talking, please put them in the Q&A, and then we will get to those at the end of today's program. But we do have about, it looks like 700, we'll probably get 800, maybe 900 people on today's webinar. And so it does take a while for those to get processed. We, Tree Fund, will be submitting your CEUs. You don't need to put that in the chat. When you signed up and you registered, we got all of that information. It should take about 4 to 6 weeks for those to get processed. And when they do get processed, I'll send an email saying, look in your ISA account, see if those are there. If at that time you don't have them, please let me know, and we'll make sure we get that put in place. Clayton is currently pursuing a Bachelor of Science in Nature Resource Management with a concentration in forestry at Abraham Baldwin Agriculture College in Tifton, Georgia, and will be graduating this December. Clayton received a 2025 Robert Felix Scholarship from Tree Fund. Every spring, we have a scholarship programs open, and this past spring, we awarded 9 $5,000 scholarships to upcoming upcoming students that will become part of our industry, that will become arborists down the road. And so one of our goals is to support and grow the future of the arboriculture world. But before returning to school, Clayton served our country for 6 years in the U.S. Army in the aircraft systems as an aircraft systems maintainer. And today, he, as well as being a full-time student, graduating in December, he works as an urban forestry technician for the city of Tifton. And he earned his ISA Certified Arborist credential this past January. So everyone, please help me welcome Clayton, and Clayton will introduce himself as well in our speaker. Clayton?
Thank you. Good afternoon, everyone. My name is Clayton Mahoney. I'm honored to be a 2025 Robert Felix Memorial Scholarship recipient. As he said, I am currently attending Baldwin Agricultural College in Tifton, Georgia, where I'm pursuing a degree in natural resource management with a concentration in forestry. I have one semester left, and I plan to graduate in December if everything goes well. I currently work for the city of Tifton as the urban forestry technician. I've done that for about 2 years now. I plan to continue in the field of urban forestry after graduation. Receiving the Robert Felix Memorial Scholarship has helped ease the financial burden of my education and has allowed me to focus more on my studies, gain valuable industry experience, and continue working toward a career in arboriculture and urban forestry. I am incredibly grateful for the support and investment from Tree Fund into my future. It is now my pleasure to introduce our speaker, Dr. Thomas Whitney, who is a technical advisor with Davey Tree Expert Company, providing support through the Pacific Northwest United States and Western Canada. He holds a Bachelor of Science in Biology, a Master of Science in Entomology, and a PhD in Forestry and Natural Resources. He specializes in insect pest of trees. Today, he will be presenting the findings from his 2023 John Z. Dooling Research Grant titled Efficacy of Aphidoletes, Predator Releases to Mitigate Aphid Populations on Linden Street Trees. Please join me in welcoming Dr. Thomas Whitney.
You.
All right. Thank you, everyone, for that wonderful introduction. Thank you, Bo, Clayton, Heath, and the Tree Fund for having me today. I'm very humbled by this worldwide presence to see the results of this research. Before we really get into things, I want to share two slides. First one's happy, the second one's a little bit sad, so just bear with me. The happy slide is a big thank you to Tree Fund and the John Dooling Grant. Without this generous funding, I wouldn't really have been able to get this research off the ground and do it justice. We have a really robust data set, and I'm looking forward to continuing the analyses and getting it ready for publication. Part of the money, actually the lion's share of the money, went toward funding this wonderful undergraduate student to do probably about 75% of all of the data collection in this project. His name is Chris Rivera Garcia, and I have the unfortunate news to share that he did pass tragically earlier this year due to a complication from a surgery. So I dedicate this work to him. I apologize for slipping this in here, but I feel like it's important. He was such a bright mind. He became a friend and a colleague, not just a protege. He was really going to move mountains, I think, in science, in his own route that he chose. He was an aspiring entomologist due to this work, and the Tree Fund will ultimately be part of his legacy. So thank you again, Tree Fund. And thank you for listening to this. Okay, let's get started then. Most of you, I think, are in the field of urban forestry or perhaps arborists yourselves. And as arborists, we need to be equipped with the skills to do some of the most complicated tree surgery projects. But as part of kind of a holistic tree and landscape management program, we also need to be able to be stewards of people's landscapes, and that means addressing pests and diseases. So I want you to sort of think about your own experiences, but maybe also put yourself in the shoes of an arborist conducting pest management. You're not a corn farmer. You're not a nurseryman or even a greenhouse manager. You operate in a vast urban landscape that is mosaicked with all kinds of different hardscapes and different plant materials and therefore different pest and disease challenges. We're kind of up against it. Tell me if this sounds familiar. You get a call from a potential new client to look at just a handful of trees, or maybe just a single tree, to address a problem that has already started to manifest and establish, and you're being tasked with fixing it kind of on a dime. So you would imagine it would be difficult to reach these aspirational ideals of integrated pest management. These are the fundamentals of IPM as I see it, kind of distilled down. The first is setting action thresholds. In the urban landscape and for a client, what is the action threshold where you would enact pest management? For a corn farmer, it's pretty quantitative. Where does that cost of doing nothing exceed the cost of control? Number two, identification and monitoring of all three of the plant material hosts, the pests, and the diseases. You can just think about how that is a challenge somehow in your line of work. Number three and four, prevention and control, proactive and kind of reactive addressing of the pests and diseases. Those present its own challenges too, compared to our farmers perhaps that are only having to deal with a monoculture in one single spot where they can kind of plant themselves 24/7, 365. So I want you to think about your own challenges. These are the ones that I see for you arborists to enact sound IPM. The first is that we have very little input on those preventative practices on our clients. We're not there at the inception of the development. Otherwise, we wouldn't be scraping out all of the soil. We're not there most of the time when they're planting. Unfortunately, it would be very nice. And we're also not there when they are doing or not doing some of the most basic cultural practices. Additionally, speaking of clients, a lot of times they have fairly unrealistic expectations. They can expect instant results. Maybe their tolerance for pests is zero, which isn't very realistic in a lot of circumstances. And like I mentioned earlier, they take a more reactive approach. They're not quite focused on their landscapes like we are in the industry, so they aren't able to anticipate these issues until they happen and until they're at their peak of their problem state. Additionally, timing. Timing is such a huge issue I can see in our industry. Not only are we working across these vast market areas with different microclimates, we're trying to run a business here and we're sending crews out every morning to different areas and we're having to deal with weather. How do we schedule and how do we logisticize our various plant healthcare programs? And then lastly, and this is huge, it's really kind of the foundational problem, I think, is we're not on site at every one of our clients' properties every day. So monitoring to the standard that IPM sometimes requires is not feasible. So what does this incentivize? The first thing is inspect and treats. I have somewhat of a love-hate relationship with this. I think oftentimes when we sell an inspect and treat, ostensibly it's supposed to be, well, it's just a monitoring service. We'll sell 3 or 5 inspect treats a summer, and when the tech goes out, they're supposed to monitor. And if there is something to do, then they will do it. But if there's not, they should just monitor and say there's no pest to treat. But unfortunately, due to client optics, we just kind of end up spraying and praying a lot of the times because it looks like we're doing something. Additionally, this can incentivize broad spectrum chemical pest management where multiple pests are affected and by extension, their natural enemies as well. And also long residual chemicals, things that to get around the timing issue, let's just put something on the tree that will stay on there very long. So this really lacks a targeted approach that would be preferred. So if we look at this pyramid of integrated pest management tactics, where the most preventative and least toxic and most preferred methods are at the bottom, and the more intervening and toxic and least preferred methods are at the top, it's no wonder that most arborists are really oftentimes just going to reach for that jug on the shelf and go straight to the top for the conventional pesticides in most pest and disease situations. It's understandable, and I share their plight. Oftentimes, these chemicals can achieve very satisfactory short-term results. And given that we aren't really able to influence or be a part of a lot of the cultural management on properties, even though I really stress this is important, um, this is all we can really do. So this is why I'm setting all of this up to introduce the idea that we really haven't explored biocontrol adequately, in my opinion, in urban forestry, in arboriculture. This is still, we are intervening a bit. We are kind of introducing new organisms to the environment. We are changing the ecosystem a bit, but it is a lot less intrusive or toxic than these chemical pest management strategies. There's a reason for skepticism. In traditional forestry, there have been numerous failures and some tempered successes, but there really hasn't been much investigation in the urban forest. It's, like I mentioned before, a very complex system, but we really just haven't tried it. Are there commercially available biocontrol products that we can simply just release and have some effect on some of our either benign or more serious pests? That's kind of the overarching question that inspired this research. So let's just talk about the type of biocontrol I'm interested in. Quite broadly, this is augmentative biocontrol. We're augmenting the natural enemy community, supplementing the natural enemy community with predators or parasitoids that ostensibly already exist. We're just putting more of them out there. Two types of augmentative biocontrol. First is inundation. This is really just putting lots of organisms out there with the expectation that those released organisms are going to do the control. We would expect a short-term knockdown of pests and no generational turnover of these released organisms. So things that we already apply in a chemical pest management fashion, like BTK, Bacillus thuringiensis, or spinosad, those are biopesticides that could be considered inundation biocontrol. Also entomopathogenic nematodes. Sometimes out here in the West and in BC, we drench the soil with nematodes for black vine weevil. This is great. However, I'm more interested in the second type, inoculation biocontrol. This is where we release a small number of biocontrol individuals with the expectation that its offspring and its offspring's offspring will provide season-long, more long-term control over a growing season. A classic example is in greenhouses with this small egg parasitoid Incarcia formosa. There's other examples as well, but fewer in outdoor systems. So that's kind of the goal here. Can we release something kind of early in the season and provide lasting season-long control in the urban forest? So the pest that I'm targeting with this research project, I intend to kind of explore this more during my career with different pests. The pests I'm looking at are aphids. They're very ubiquitous in every system of horticulture, ornamental, or agriculture. But they're so ubiquitous on our urban tree species, especially those that are pollinator-attractive, which presents an additional layer of concern when you talk about chemical pest management. So things like lindens and tulip trees and birches are kind of your quintessential aphid magnets here in North America. And they reduce the vigor of the tree. They're feeding on the tree's phloem, the vascular system. They rob the tree of those sugars that it just produced. But really, they're not that big of a concern. They're sort of benign for the health of the tree in most cases. It's really the honeydew, that byproduct that they are dropping down, that they're sort of extracting sap, and they are a factory refining the nutritious nitrogenous compounds and expelling this sticky, sugary waste product all over the place. So these are photos from my research on lindens. You can see how sticky and liquidy and gummy it is. Take a look at this photo. This is under one of the linden trees in the study, and this is normal street out here, dry. Under this canopy, it's just completely lacquered in honeydew. And you can see why clients would call about this. They're getting their lawn furniture, their deck, their cars just covered in this stuff. So it's really more a nuisance pest. We really don't want to bring out the big guns in terms of chemical pest management, especially on a linden that could be exposed to bees for something like aphids. So what is out there that we could release for aphids? Lady beetles, lacewings. Those things are fine and dandy, but they tend to fly away. This is the candidate biocontrol agent that we were interested in exploring. It's called Aphidoletes, aphidimyza, or the aphid midge. It's a fly, kind of looks like a mosquito. It's part of this family of flies that make galls, but through evolutionary time, it decided aphid predation was its strategy. And it's very common. It's among the top 10 used biological control agents in the world, but mostly for greenhouses. It has been explored a bit in some small controlled outdoor settings, mostly these specialty crops, with some success. So we wanted to test this out for a few reasons. What makes this aphid midge a good candidate for the urban forest on urban trees? There's 5 characteristics. The first 2 are pretty prerequisite. First, it's native to North America, where we're trialing this out. Since we have a worldwide audience, though, I'll point out it's really native to the whole Nearctic. So sorry, South America, I think it's just naturalized there, so you may have to determine if it's safe to release it. But Asia, Europe, North America, it should be good. And more importantly, it's widely commercially available. It needs to be for arborists to be able to get it when they need it. Third, it's a very effective natural enemy. It's super aphid hungry. It is just a voracious aphid predator. One larva could consume up to 30 aphids during development. Females have these long antennae. This is actually a picture of a male. I apologize. It has additional hairs with pores to detect the pheromones of the female. But the females have these long antennae nonetheless, and they're adept at sensing honeydew. There's this great anecdote from this paper here in the corner from 1974 where they put 75 pepper plants in a greenhouse. Only one of them was infested with aphids. The rest were clean. And then they released a single female at the other side of the room. And it only took 2 minutes for that female Aphidoletes to find the moving on, they lack specific aphid preferences, but they also will not get distracted on alternative prey. They're really aphid specialists, which is nice for our purposes. And then the last characteristic, and really the most important, is that they have a very limited dispersal ability. These guys are very weak flyers. And so unlike a lady beetle, unlike a lacewing that are strong flyers, we suspected that at the point of release, they would have very high site fidelity. If we put them in a nice shaded, moist, canopy of a tree with a little bit of honeydew, we suspected that they would stay put and not to be tempted to venture away at other trees. So let's set this experiment up. Really, our objective here is to determine if an early season release of these Aphidoletes could turn over in population and establish on a single tree and reduce the aphid densities over the growing season. Really, the steps are simple for an arborist perspective. Monitor for aphids in the early season and then release predators when aphids first appear. They do need a food source in the beginning. Some sub-objectives that we'll get into. I wanted to determine if there's any year-over-year control. They pupate in the soil, so potentially they could overwinter and provide control the following year. And secondarily, we wanted to test different products. You see here 3 different products. The third year of the study, we tested 3 different products. Okay, so these are the methodology, the experiment. We did this in Portland, Oregon. A lot of people from Portland I saw in the chat. Here you have the mighty Columbia River, and it meets the Willamette River here. This is Portland. And I chose lindens, and specifically linden street trees. I collaborated with the city of Portland and found a number of lindens on their street tree inventory. And I think street trees are a really great real world petri dish for studying something like this. And I hope that work like this inspires more research on street trees, because I think it's an untapped laboratory, if you will. So the experiment was quite simple. Each year I'm going to release these predators on half of the trees in the study, and the other half will be control. I think in the end I actually landed on 62 trees. Some were cut down, etc. But we have kind of a nice smattering of trees, and they were all separated by at least 100 meters beyond the known dispersal range of one of the females. The product I chose in the beginning was this little vial product, but all of the products are very similar. They're pupae in some sort of carrier like vermiculite or sawdust. And so the idea here really, if you look at this video in the center, is these females kind of emerge from the pupae and then they just emerge throughout a passive dispersal window here, this little hole. And then again, in the third year, I did a product comparison. The second product I chose was this little blister pack, very similar to the vial. There's a little hole in the back. The pupae are in sawdust here. And then this one, it was a cheaper option. You just kind of buy the pupae and vermiculite in bulk and then pour them into this open box. The disadvantage here is it's not very protected from any potential rain. So I had to sort of work around the weather to release these. I'm sure you could come up with something to add to it, though. Okay, aphid counts. You got to be picturing me and Chris here. We're driving all across the city from tree to tree to tree, counting aphids. We needed a very fast proxy and an accurate one to estimate the total number of aphids in a tree. So we scoured the literature and found this method. It's called the most infested leaf per shoot method. We chose 4 random branches per tree, and we only recorded the most infested leaf on that branch. So if you can picture this branch here, we're kind of turning over each leaf quickly. If there are aphids, we count them, but we're only remembering and recording the most infested leaf and moving on. And there's good evidence to show that that's a good proxy for total aphid density. This allowed us to go quickly because a lot of drive time. So this first year released very end of May. That's kind of when we found that aphids start getting going in Portland on linden trees. And then every other week we did an aphid count. So usually every year there's about 8 aphid counts. So let's get into the results. I want to show you kind of just broadly aphid densities. Let me orient you here. The blue is going to be control, release going to be orange. On the y-axis, we have aphids counted per tree. And again, this is 4 leaves total, 4 branches, and the most infested leaf per branch, just added together, a sum. So the aphids counted per tree is somewhat of an arbitrary value, but it's a proxy, again, for total aphid density. And here we have date. So we released very, very end of May, and then I show you here our last count where the population crashes. So what happens in between? Well, aphid densities start to increase slowly, and these midges do take about 3 weeks in order to for larvae to really start emerging from that first generation. So right up until the end of June, not very many aphids until beginning of July, and we are seeing a very interesting separation between control and release trees. Here at the end of July, we have a peak of aphid densities, about 3.5 times as many aphids we counted on control trees compared to release trees. And then we have kind of a slow and steady decline. So this is very timely in 2023. We had just been through COVID and we had remembered this whole concept of flattening the curve. And that appears to be what we achieved in this first year of data collection. I have here at 10 aphids per tree. I've put this kind of line here. It's an arbitrary number to remember throughout the rest of this talk, but we kept aphids below this line on those release trees, whereas on the control, they really skyrocketed. So we got really excited about this research, and this is what sort of inspired me to apply for funding. We got Tree Fund Research to continue this and expand into 2 more years. So now I'm going to share 2024 and 2025, and this is why you do multiple years of research, because sometimes a result one year is not what you get in the following years. Let's take a look with that promising foreshadowing. So here are the control trees in 2024. As you can see, none of the dates did we count aphids getting higher than this arbitrary 10 aphids per tree. Overall, a much lower aphid year, which is interesting. Let's look at the release tree numbers. Overall and statistically, there was no significant difference among any of the dates. Even this one here, it just didn't print the error bar. Effectively, there was no control provided, additional control provided by these Aphidoletes in year 2. But I would argue if you released these midges on a client's property, since it was such a low aphid year, you would still look pretty good. There just wasn't any added control at those low aphid densities. This is also the year as part of the grant that I wanted to test if there was any year-over-year control. So we just did a 2x2 factorial design. We reassigned the tree treatments. Half of the release trees from 2023 were now control, and half of the control trees from 2023 were now release. And it's a bit messy, and that's kind of the point. We would expect if there was not any year-over-year control that the beige line, the year 2, and the both line, the dark brown, would be lower than the 2 blue lines. But we're really not seeing any separation of concern here. So whether or not we had enough aphids to really test that out in the field is a question I'm going to dig deeper into. But we didn't find any year-over-year control. So yeah, that's research, right? What about 2025? Would we get more aphids here? Again, this is the year that I tested multiple products, all 3, the vial, the box, and the blister pack. And unfortunately, potentially, because I had to logisticize all of these 3 products and there was the concern of weather with this box, we released kind of late. And as you can see, the number of aphids starts a lot higher this year than in previous years. Previous years, there's much more of a slower buildup working its way into June. Here, it starts very high in June. And we get a peak in July, and then it really just tails out, and no aphids from mid-July on. Very different. Aphid dynamics year over year are kind of a mystery in itself that I'd like to explore further. What about the release trees? Pretty similar. We did get a numeric reduction in aphids overall in July. However, it was not statistically significant. So this was also a bit of a failure. Probably we released too late. That is my guess. If you look at the differences in products, interestingly, we did have a winner potentially. It probably deserves another year or so of looking into this. But the open box actually had fewer aphids on its trees. Just because of the nature of splitting up the treatments like this, we only had about 15 reps per treatment. So the sample size is not nearly as robust as just testing control to release. So keep that in mind. But perhaps there's something here. Maybe there's trouble with the females escaping from the smaller windows. Or maybe it's just a superior insectary, or maybe it's just a fluke and it needs more research dedicated toward it. So what I want to sort of kind of summarize this, because this is interesting to me. I think we do have something here. It's going to require more analyses. There may be some temporal density dependent mortality occurring. So this graph is a bit confusing. Let me walk through it. This is the aphid density ratio comparing the density of aphids on control trees to release trees. So a ratio of 1 would mean that they're equal on any given count date. And then on the x-axis here, we have the mean number of aphids per tree per date across all trees. So this is just kind of looking at the relationship between how well control occurred on a single date versus the total number of aphids. And what you see here is potentially a linear or some sort of relationship where as the number of total aphids increases, usually in the July months, we are seeing more mortality in the release trees. I'll say that again. As the total number of aphids increases, just, study-wide across all lindens, we are seeing more aphid mortality or fewer aphids on the release trees. So what does that mean? It means that when aphids are low and there's not much to eat, the predators aren't going to do much. But when it's a high aphid year, you might have better control. Might. So I'll wrap that up later. There's a few other variables that we decided to add. This is a snapshot of one of our data sheets. We did a just binary presence absence, yes or no. Are there parasitoid mummies? Is there honeydew on the tree? Or are there ants? And I just want to show you those data. First, honeydew, presence absence. Is there honeydew? On most of the trees with aphids, there is some amount of honeydew. Really, the threshold is there enough where you're getting your hands sticky on every single, leaf? Just a little bit here or there, we marked a 0, but like is every leaf covered with some amount? So it's not that great of data, unfortunately. We tried to quantitate honeydew drop with various other methods that didn't work. But you can see at a glance that first year, the high aphid year, we do get a lot of divergence between the control and the release trees. 2024, 2025, not so much. Ants, I get this question a lot. Don't the ants tend the aphids and protect them from predators? Won't they just eat your flies? At least in Portland on the lindens here, they don't. I didn't observe any sort of ant tending, and really the ants weren't a major player, and that kind of bears out in the data. most of the ants we saw were sugar ants. And so in that first year where you had a lot more aphids and therefore honeydew on those control trees, there were more ants on those trees. But otherwise, there wasn't a big difference. And lastly, mummies, maybe just a proxy for the natural enemy community. We saw more parasitoid mummies on the control trees, more aphids in that first year, and a lot less divergence in these following years. Interestingly, though, this date diverged, so that warrants more investigation. Okay. So, can an early season release of Aphidoletes reduce aphid densities on these single urban landscape trees? It's quite a stress test. The answer is potentially yes. It's not a slam dunk. I'm going to be very tentative to recommend this wholeheartedly to my arborists. But potentially as part of an integrated pest management approach, it can be a helpful component, especially in those high aphid years. Hard to anticipate, we think, before it's time to release them. But really, timing seems to be a crux here. I think in that third year, I didn't quite get the timing right. In that first year, I just happened to have nailed it. So I'll share with you some future ideas I have in a second that maybe can address the timing issue. But what am I kind of thinking about and working on now as I wrap up this project and begin to get it ready for publication? The first is reviewing the climatic data. Is there an explanation for the wide variation year to year in aphid densities? That's really interesting to me. Where we released the Aphidoletes the first 2 years, the degree days were almost exactly the same. They were a lot higher that third year, which again leads me to believe that I was a bit late. Is there something to glean from precipitation, perhaps? I'm going to look into lots of variables based off of publicly available climatic data. The second thing I'm working on kind of in a post hoc fashion is already went back to these trees and I measured the amount of non-porous surfaces underneath the drip line of the trees. And I want to see if there's any correlation between aphid control and the relative proportion of non-porous surface underneath. So if you look at this tree, there's only this tiny little tree well here, maybe 90% of its drip line is concrete or asphalt, whereas these two trees have a lot bigger proportion. It's turf. And then if you know Portland, Oregon at all, people love to put very intricate gardens in the right-of-way planting strips. What effect does that have? Remember, these midges, in order to pupate, need to drop from the leaves, go into the soil, a very superficial amount, and pupate there. So it's possible on a tree like this is really the only individual that was quite this exaggerated. It's quite possible that we're not getting any generational turnover on a tree like this, whereas we might be getting some, or at least a lot more, on trees like this. Then I'm also doing kind of a very reduced fourth year of research right now. I had to cut sample size down now because I don't have the help. But the rub here is I'm testing serial releases. So that's how I'm trying to get around the timing. In those first 3 years, we really just put out one Aphidoletes product when we thought, okay, aphids are now appearing. But as we know with arborists in the real world, nailing the timing is difficult with sprays as well. So this is how we hedge our bets. We come back week after week. I put out 3 vials for the latter half of May, and that should do well here. And it just happens that so far it is a very, very high aphid year. So really we should be putting this to the test in a good way. And then kind of as a footnote, I'm also surveying the natural enemy community this year, just monthly, probably just going to do it 3 or 4 times with a beat sheet and counting all of the natural enemies that I find. The reason here is just to sort of see potentially if there is any difference in the control versus release trees. Are the Aphidoletes displacing or reducing the prey for the natural enemies that are more common in the landscape? I see a lot of lady beetles. I see a fair number of lacewings. Definitely get a lot of parasitoid mummies. They probably won't fall out in the beet sheet very much. I get earwigs and snake flies, all kinds of stuff that don't really feed on aphids, but nonetheless, it'll be informative. So this is kind of an old slide now. These prices are outdated, but the question I pose is this biocontrol option a cost competitive alternative to something like insecticidal soap? By the numbers, it does appear so, and the labor is pretty much zero. You, as a manager or sales arborist, can go hang this in the tree yourself. You don't need the technician necessarily. And especially with the media attention and the scrutiny on neonicotinoids and chemicals for aesthetic purposes in general, I think it's important that we explore these in a robust experimental fashion, explore these biocontrol options. And it does appear that we can have some success. I will share with you an anecdote. I have been rolling this out with caution to my BC offices. In Canada, they are very limited in what they can apply chemically to urban landscape trees. So they champ at the bit for anything that they can use. And so as long as they sell it as an experimental treatment, I allow them to. And this person thinks that they have really good results. They say, I've had great results, both with releases on single trees and alternating releases on groups of similar trees. They can knock down a heavy infestation within a few weeks using a single release, saving the client the cost and bother of multiple pesticide applications. So maybe there's some bias there. They want it to work. But nonetheless, this shows kind of the excitement and the anticipation for alternatives to the jug on the shelf. Thank you guys very much. I'd like to acknowledge all these fine people. Again, Tree Fund again, the City of Portland, and Friends of Trees. I'm happy to take any questions. Thank you.
Dr. Whitney, thank you very much. Fantastic presentation. That was very enjoyable. Thank you. We do have a number of questions in the Q&A box, and I'll kind of run through those. For those of y'all listening, we're not going to be able to get to all of these. I apologize, but I'll do my best real quick. The first question that came up is, have you noticed more infestations in monoculture plantings, street trees, for examples? The person notices that there seem to be larger aphid populations.
That's a good question. So in my study, I purposefully only chose single lindens on a particular block, and I used a GIS tool to make sure it was at least 100 meters away from a neighboring linden. There's tons of boulevards in Portland and probably all over the continent and the world with lines of lindens. In fact, I can think of one right now in southeast Portland. I haven't noticed any particular difference. It would stand to reason that the winged aphids would be able to infest near neighbors quicker. But I tell you, some of my lone wolves, if you will, get very infested. So the jury is out. But yeah, it would stand to reason that lines of lindens would get infested at least quicker, maybe not worse.
Thank you. There was another question about something asking about what climatic zone this aphid midge would work on. I know you showed the map. Do you know if there's like a hardiness zone where it would work or whatnot?
That's a good question. I don't remember off the top of my head. They are hardy, but to a degree. Again, it was sold to me by some of the distributors that since they pupate in the soil, they can actually overwinter in pretty cold conditions. And then when the soil temperature rises to a certain level, that's when they start to emerge. So I would imagine that the hardiness is fairly high since that's their overwintering strategy. But they can definitely hang out in the tree above, just right above freezing, no problem, as adults and larvae.
Thank you. We have a couple questions about the use of this control method in Canada and, if it's being used. I think you mentioned that for research purposes it can be used. Could you elaborate on that?
Yeah, so I know of plenty of outfits, not just my company, Davy, that are using these. That's actually the inspiration for this project. It was really kind of that need from the field and from my Canadian offices. And that first product that I used was a vendor out of Victoria. Um, so they're being used. It's legal. It's not regulated by the PMRA because it's not a pesticide. I would just the reason why I worded it the way I did is because it's not a slam dunk. It's not providing aphid control in all situations, based on aphid density. And because timing is so critical, I'm not writing this up in our treatment guide and giving it to them wholeheartedly. I'm saying you need to communicate to clients that this is still an experimental treatment option for the context of an urban tree with a lot of promise. Um, just want to hedge our bets, and I think the ethical thing to do, at least in this at this juncture, is just not to overextend our promises.
Well, that's a great answer. Thank you. There was a couple questions related to whether the predatory control would last more than 1 year, or if it's something you had to reapply every year.
Yeah, that's a good question. I think us arborists would prefer if it did not. Then we could sell it annually, right? I attempted to test that in year two. Unfortunately, I just don't think we had the aphid pressure to really adequately give a solid answer. Hypothetically, it should. In greenhouse settings, supposedly, because it's so controlled, they can provide up to 5 years of control. You'll still be getting, like from a single release in year zero, you'll still be getting aphid midges pupating in the soil and providing control in year five before you need to add more. So hypothetically, in a nice backyard, maybe that's really well mulched and landscaped, maybe not a lot of like uh, chemical inputs on their lawn. Hypothetically, yes, you might get some residual control, but I would recommend if you're going to implement this as part of your management program, do it annually and maybe do serial releases like I'm trying this year in year four.
Thank you. And I think I have one time for one more question. And somebody asked, if in your study, if the weather fluctuations in summer might have had some impact on aphid populations that, either especially hot, cool. Did you take that into account when you looked at your study? Weather
I
fluctuations.
haven't yet. I intend to really pick that all apart. It's going to be dense and time consuming. You know, sap feeding insects, it's kind of counterintuitive. We always think like tree health is number one and, irrigate and mulch and do all of these things that help promote the health of trees and then they won't get pests. But aphids and sap feeders don't really work that way all the time. They love a healthy, vigorous tree. When things are transpiring really nice, that's when aphids really proliferate. It's those drought stressed trees where they're shutting down transpiration that you won't find many aphids. And that's not a hard and fast rule. Aphids work in mysterious ways sometimes. But just because it's really hot and then really cold, it's going to take a lot of picking apart, and I anticipate it's going to be difficult to find very clear patterns, but I will try.
Thank you very much. Y'all, with that, I think that brings us to almost the top of the hour. Dr. Whitney, thank you for a very fantastic presentation. You're a very engaging speaker and a fantastic topic. So thank you for joining us on the Tree Fund webinar series. Good luck getting this published. And for all of y'all listening, this is really cool to see some research that is not even hot off the press. It hasn't been published yet. So this is really cool to kind of get an inside look. So Please remember, we'll be back with the Tree Fund webinar series again next month with Heap Hubkey. Keep an eye